Alright, uh, good day. Welcome to today's chemistry class. We are looking at matter, and you look into the bracket, you see substance. If you're taking chemistry course for the first time, it should be good for you to understand that chemistry has the basis, has the foundation. And it's not good if someone wants to build a house and it doesn't consider the foundation before building the house. That's the problem of so many students, because they lack the fundamental knowledge which is needed in chemistry. And then if you're taking chemistry for the first time in high school, in college, or in secondary school, this lesson is for you. Or maybe you are finding chemistry difficult, this lesson is for you. In our series of lessons for chemistry, in chemistry for beginners, you need to follow us so as to get more of it on the preceding lessons. Now, the chemistry for beginners, we need to take the terms as simple as possible. Chemistry, if you are asked, is the scientific study of matter, the properties of matter and the behavior of matter. I take it again. Chemistry is the science that studies matter, the properties of matter and the behavior of matter. Chemistry studies matter. It studies two aspects of matter: properties of matter, and the behavior of matter. And then if you are asked what matter is anything that has mass and occupies space. I'm sure you should know that by now. Well, check it again. Matter is anything that has mass and occupies space. And in chemistry or chemists, we see matter as substances. We see matter as substance. So when you hear me use the word substance, you know I'm referring to matter. Alright? Now, we need to know that there are two major properties of matter. The properties of matter is divided into two. We have the physical property, and then we have the chemical property. Alright, what's the difference between the physical property and the chemical property of matter? The physical property is telling us what the matter is, what the substance is. Let's use the word substance. The physical property tells us what our substance is. The chemical property tells us what our substance can do. Alright? What a substance can do. Put a question mark there. What a substance is, that is what the physical properties is talking about. And then what a substance can do, that is what the chemical properties is talking about. And then if you're asked to define that, you will say that the properties of matter is the state of matter when there is no observable change in its constituent. Well, the chemical properties is telling us the behavioral aspect of matter, or what matter can do, whether it can react or it cannot react. Now, the physical properties of matter, examples is the color, the texture, the density, the boiling point, the melting point. Alright, we have the spectroscopic properties. Alright, what I mean by spectroscopic property, I mean the radiation, infrared radiation, we mean ultraviolet radiation, and the NMR. Alright, this spectroscopic property is also a physical property of matter, but it's talking about the radiations that substances absorb and the radiations that they give out. That will be found under spectroscopic properties of matter. Then, under the chemical properties of matter, we are talking about the flammability of matter. Flammability. This is talking about whether the substance is able to undergo combustion. Can it burn or can it not burn? Then we have precipitation. Under precipitation, we are talking about can the substance dissolve in water or dissolve in a solvent, or can it not dissolve? Then we also talk about decomposition. Then this can be seen when you are talking about decaying of organic matter, even the decaying of woods, that is under decomposition. And then we have the rusting of iron and souring of milk. Alright? The souring of milk is done by bacteria. When bacteria act on milk, it can cause the milk to sour. Now, you cannot see that the difference between physical properties is that this one can be dictated using your physical senses, or the spectroscopic pattern can be dictated using a simple instrument in a laboratory, while the chemical properties can be dictated not with the physical property, but by looking physical senses, but by looking at its ability in this perspective. Now, from these chemical properties, we move to the behavior of matter. Now, before we talk about the behavior of matter, you can be asked the question, what is the difference between physical change and chemical change? I'm not going to take much of your time. I'm just going to give you a table. Okay, let's take a table. Let's say this is physical change. Let's use delta for change, chemical change. The first thing you should know about physical change is that no new substance is formed during physical change. No new substance. Here, new substance are formed. New substance are formed. Okay? New substance is not formed, new substance is formed. Now, over here, there is no or little amount of energy that will be emitted. There's no or no energy or little amount of energy as needed. All right, just you can write there. Just no or little amount of energy needed, but a considerable amount of energy is needed. I'm trying to look at the way I can fix this inside this box. But let me take it again. No new substance is formed. New substances are formed under the chemical change, and then no or little amount of energy is required. Considerable amount of energy is required. Now, over here, we can also finally see it is easily reversible. Easily reversible. This one is not easily reversible. Alright? You cannot easily reverse a substance that are decomposed. When a substance, when wood have decayed, or when organic matter have decayed, you cannot easily reverse those organic matters. When a substance or a material has been burned, you cannot easily recover the material again. This is under chemical change. And then the physical property, you can easily recover either the color, the texture, density, boiling point, or melting point. So this is what we're talking about. Now we're moving to the behavior of matter. Now, in this video, we are considering just properties of matter and the behavior of matter. I can erase the board now. Let's take this one away. Under the behavior of matter or substance. Now, the behavior of substances is based on the components or the composition of substance. Every substance or matter is made up of atoms, elements, molecule, compound, and then matter, or known as substance. Okay? Every substance or every matter is made up of atom, element, molecule, compound, and then the matter. There's an exception to this rule. If you are talking about the non-metals and metals, they are different things. Alright? Now, when you look at the periodic table, you'll find out that the periodic table has both metal and non-metals, and also the metalloids. If you're talking about the non-metal, the composition of the non-metal is basically the atoms, the elements, the molecules, and then the substance. Or you use the word matter. Then for the metal, you consider the atoms, the elements, the compound, and then the substance or the matter. Notice that over here we're talking about molecule, over here we're talking about compound. I'm going to explain what that means in a nutshell. Stay with me. Now, let's talk about the non-metal, the composition of the non-metal. Alright, now, in the non-metals, we are talking about having atoms. We have atoms, and then we have elements, and then we have molecule, and then we have matter or substance. Alright, but in most of the textbooks, and in some of the textbooks, you might have atoms, and then you might have molecules, and then you will have the substance. Now, the molecules has either one or two atoms combined together. Of course, atoms of elements. That's why we have the element, then the molecule. Most of the textbooks we have it, atoms, molecules, and substance. But that molecule must be an atom of element. Not just be an atom, but atom of element. Then combines together to form a molecule. Now, we're looking at these molecules, and then we're going to find out that we have different types of molecules. They start off from diatomic molecules to polyatomic molecules. Now let's show you what we mean by that. Now, if an element is made up of two types of the same element, we're talking about a molecule, or two types of different elements made up together and is a non-metal, we're talking about a molecule. Now, let's look at some diatomic molecule. Okay? Alright, some of the diatomic molecules that we have is the hydrogen, nitrogen, oxygen, chlorine. Alright. Now, these molecules or these elements or atoms of elements combines to, you notice there are 2, 2, 2. Now, appearing in 2, or when you see them in this form, they are called molecules because they have undergo a reaction. Before now, or prior to this time, hydrogen tends to exist alone. And then if you have hydrogen, which has one valence electrode reacting with another hydrogen, which has just one valence electrode, there will be a sharing of electron from these two hydrogen. And then we're going to have 2 electrons here. And then having the 2 electrons, what we're going to have in the Lewis structure will be this form. And this can also be written as this. So this is a molecule of hydrogen. And then if you want to see how these nitrogen, oxygen, chlorine can be written in the molecular form or the Lewis structure, you need to look out for a subsequent video on pure covalent bonding. When you get to that video, you'll find out where we discuss pure covalent bonding, and they will show you how these things can bond together to form molecules. I think that would do good for you. If you are interested, you can check out the video if you will. Alright. Now, and also in that video, we'll talk about homonuclear molecule and heteronuclear molecule. Now, when we talk about homonuclear molecule, the things I just wrote prior now, they are homonuclear molecule because they have molecules of the same kind. Hydrogen, hydrogen, 2 of them, 2 hydrogen, nitrogen, nitrogen, 2 nitrogen, chlorine, chlorine, 2. But when we talk about heteronuclear molecule, we are talking about molecules of different atoms coming together. But notice there must be non-metals. They are non-metals. All right. Now, if you look at this polyatomic, now under the polyatomic, I will talk about the carbon dioxide is a polyatomic element. HCl is a polyatomic element, and then we have other ones like P8, that is phosphorus, is a polyatomic element, and so on and so forth. Alright, now I will only pick one of these, and then I'll write out the Lewis structure or the way in which the atoms of elements combine together. And I tell you that every atom of element wants to be stable. That's the idea why they are forming molecules. Elements they are on their own, but because they want to be stable, they tend to react with other elements. The reason of that reaction, or the reason why they form molecules, is because they want to be stable. And for an element to be stable, it must be either duet configuration or octet configuration. But all these things I'm saying is in that video where we'll be talking about chemical bonding alone. But over here, we're considering chemistry for beginners. So let's stay with the prerogative for the class. Alright, we're looking at this hydrogen. Hydrogen, which has one valence electron, it reacts with chlorine, and then chlorine has 7 valence electrons the atom share, and then is going to form an hydrogen chloride. This will also be written as this. Notice that you have 2 electrons, which makes this hydrogen balanced, because hydrogen needs just 1 electron to become duet, which is 2, and it's balanced. And then chlorine needs 1 electron to become octet, which is 8, and we're balanced. Let's look at this. 1, 2, 3, 4, 5, 6, 7, 8. You see, that's complete. Now, why we writing this is not the prerogative for the class, but we need to show you what molecules look like. That's why we're writing all these things. Now, let's go to the next behavioral aspect of substances, which is talking about the metals. All right? Now, for the metals, what we are looking at is the ability of these elements to combine with other elements. Meanwhile, elements like sodium is alone, is an element, and then element combines with other elements because a molecule contains 2 or more atoms of elements, while a compound contains 2 or more elements. Are you following that? Now, but this is for metals. Now, for the sodium metal to become unipositive, it must give out an electron. So this is called a oxidation. Now, we also have another element like chlorine. For it to become negatively charged, it must receive an electron. So you can see what is happening here is that sodium is giving out an electron and chlorine is receiving the electron. Meanwhile, the structure will look like this. Sodium, positively charged, chlorine, negatively charged. You can see that sodium just needs to lose an electron and it will be stable, so that the outermost shell will be octet configuration. Don't bother, don't try to understand